Now, the last thing that we want to look at here is identifying rational functions from its graph, and then kind of interpreting a little bit about what's happening to the end behaviors of the graph. So just by simply looking at the graph of rational functions and substituting different values into the given function that we have, that helps us to determine the end behaviors of the graph as x is either getting really large or really small. So let's consider this function here, f of x is equal to 1 over x. So this would be the graph of that function, and just simply looking at this graph and deciding what's happening with the x value, that lets us know what's happening with the value of y. So the end behaviors of the function can be determined this way. So first we can say as the value of x is increasing along the positive x-axis. So here we are increasing, the value of x is getting larger and larger. We can see that the values of the y approach 0. So you can see the graph here is coming down, representing the values of y, and it's approaching 0. And we can see here this would be where y is equal to 0. And so we can see it's getting very, very close to the x-axis, so it is approaching 0. Now, as the value of x are decreasing, so getting smaller and smaller, so now we're going in the negative direction. As the values of x are decreasing, then we can see that the value of y is also approaching 0 in this direction as well. So we can see here, this red line represents the graph, which is also representing the values of y. So as x is getting smaller and smaller, we can see that this line is getting close to the x-axis, which represents y equals 0. So we can see indeed that y approaches 0 also as x is decreasing. Now, as x is approaching 0, we want to see what's happening to the value of y as x is getting close to 0. So now as x approaches 0, the value of y is approaching negative infinity when x gets close to 0 from the negative direction. So here we're coming in from the negative direction, and you can see x is getting close to 0 here. So what's happening with the graph now is, as we are approaching it from the negative direction, we can see that the graph is now coming down in the negative direction, and it is approaching negative infinity. All right, well, what happens when x is approaching 0 in the positive direction? So here, x is getting closer and closer to 0 in the positive direction. Well, we can see that the line here representing the graph, representing the value of the function, it's getting larger and larger. So therefore, it's approaching positive infinity. All right, so x is getting closer to 0 from the positive direction, and the line is increasing, going to positive infinity. And so to just bring back what we were talking about before with asymptotes, we can see that we indeed have a vertical asymptote here at x equals 0. And that makes sense because if we set this x equal to 0, we would get x equals 0. So that would represent the vertical asymptote. Then we have a horizontal asymptote here at y equals 0. And we know that because the degree in the denominator is understood to be 1, the degree in the numerator, where there is no variable, so the variable must be x to the 0. So the degree in the denominator is larger than the degree in the numerator. So therefore the horizontal asymptote would be here at y equals 0. So final example here, let's suppose we want to determine what the graph of this function would be. So we have the function 1 over x plus 1. We want to see which of these 4 graphs represent this function. And we want to make sure we identify any asymptotes that this function has. Well, let's first see if we can identify the vertical asymptote. Remember, we'll just take our denominator, set it equal to 0, and solve for x. There is nothing that we need to do in terms of simplifying this function, so we can go straight to setting that denominator equal to 0 and solving for x. So if we do that, we would see that the vertical asymptote would occur at x equal negative 1. Again, setting x plus 1 equal to 0, solve for x, we get x equal to negative 1. So we should have a vertical asymptote at negative 1. Now, let's see if we can identify the horizontal asymptote. Remember, the horizontal asymptote is we have to look at the degree of the numerator and the denominator. The degree in the denominator is understood to be 1. Again, there is no variable up top, so it must have the variable as x to the 0. Anything to the 0 power we know is 1. So the degree in the denominator is larger than the degree in the numerator. So therefore, the horizontal asymptote would occur at y equals 0. So now let's go through and check all 4 of these graphs and see which one satisfy these conditions. So first we say the vertical asymptote is at x equal -1. Well, if we look at this first graph, it looks like we have a vertical asymptote right here along the y-axis. So that would be where x is equal to 0. And then it looks like we have a horizontal asymptote here at 1. So that horizontal asymptote would be y equal 1. And so that doesn't satisfy our 2 conditions. So it looks like we can eliminate this first graph. Now let's take a look at our second graph here. Looks like we have a vertical asymptote here at x equal 1. And then look like we have a horizontal asymptote here at y equals 0. Well, only one condition is satisfied. The horizontal asymptote is the case that we have. However, the vertical asymptote is not. So it looks like we can also eliminate this graph. Now take a look at our third graph. Looks like we have a vertical asymptote indeed there at x equal -1. And then we have a horizontal asymptote here at y equal 0. So that looks like it's satisfying our conditions. Vertical asymptote at x equal -1, horizontal asymptote at y equals 0. So now let's check out this last one here. It does look like we have a vertical asymptote here at x equal -1. And look like we have a horizontal asymptote here at y equals 0. So it looks like this last one is also satisfying our conditions. All right, but only one of them must be the graph of this function. So remember we said that also looking at the graph we could help decide, but also substituting different values in for x will also help us. So let's suppose we want to substitute in, let's say, 1 into the place of x. Well, if we do that, we'll get 1 plus 1 in the bottom. That would be 2. So this would simplify to 1 over 2, which is 1/2. So therefore, we're saying whenever x is 1, the value of y should be about 1/2. So about here. So the line should be going through that point. So it's not happening with that last one, but let's take a look at the one before that. If we do let x be 1, then y, the function of the value of the function should be about 1/2. And so it does look like the graph is crossing at that point. So therefore, it looks like this third graph is the correct graph. And therefore, that's how we're able to determine what the graph of this function looks like.